have an issue, we don't wait for the daily standard. We just go and ask for help to this person that we know that can help us. So in other cultures, and in Germany or in Switzerland, you can believe that people is working maybe the whole day without talking to each other. Having a daily standard and being forced to have a small conversation about what they are doing is very, very helpful. So the problem with the process, when it's very dogmatic, is that it cannot so easily adapt to different cultures. This is why Scrum is something that, in my opinion, is very good for somebody coming from the old approach, because you are very structured, very organized, and you know what you have to do and the process you have to follow, but it doesn't release you from the whole thing that you need in order to be fully productive and creative in your company. The last thing you can see here is just about how the backlog is organized. Normally, people writing specifications would like to write them in this way, so very general, and all the rest of the details are obvious. Developers would like to have them like this, with a very detailed specification from end to end for everything, okay? And what Scrum proposes is that you start defining in very detail only the sprint backlog that is going to come and be produced in the next 2 or 4 weeks, and then incrementally, gradually, as longer you take, then the less granularity you have about the dependent things you have to do. The problem with this is that even having a very detailed list, nothing guarantees that what you are doing is exactly the right thing. Okay? You have a person there that is a product owner that is making the decision of what has to be done next. And this is exactly what Mary was explaining yesterday, that nothing can be worse than interfere in the communication between developers and end users. Back to this, sorry. Back to this one. Beyond Scrum, I could say that on the top of this you have Lean. Because when you have Lean, you have no rules. There's nobody telling you what to do. There's no book saying, this is what you have to do. There's no Bible, no reference, no person, not even Tom and Mary, telling you, this is what you have to do next. And this is one of the major criticisms that they have received, because people that is reading their book have to think. You have to think on your own about what is the best thing to do next. Okay? So it's quite different for those of us who are used to work within an environment that we go there, we learn something, we know how to do it, and then it's just repeating the same work again and again and again. We are not anymore in modern times, we are not anymore in this factory, we are not anymore doing the same work again and again and again. And finally, the last step, it's you, each of us. No one told Taiichi Ono, hey, this is Lean, this is the Toyota production system, this is how it works, and this is what you have to do. He needed to find it by himself. He needed to apply, basically, the scientific method. He needed to experience, to make a hypothesis, to run experiments, to corroborate them or to discard them, and then make decisions, to empower people and to believe on them, to think that the people he has are human beings with a lot of capabilities to do great things. In the introduction of Taiichi Ono's book about the Toyota production system, it is said that the person that is writing the introduction says, I've never seen a Japanese company with a person just watching a machine. And on the contrary, I've never been to a Western company that didn't have at least one person just spending the whole day simply watching a machine, just in case it fails. From his opinion, this is the major waste that you can do of any resource, and of course humans should not be called resources, okay? They are not so easy interchangeable, okay? But this is the major waste you can do in any company, okay? There are a lot of concepts that have been deformed in the communication until they come especially to countries like ours. One of them is very interesting, and with this I'm finished, is labor flexibility, flexibilidad laboral. Labor flexibility is what was introduced in Toyota in order to allow people to work on any issue, regardless if it's his function or not. If there is a problem, just go and get it fixed. And don't wait to see, is that my problem? Should I take care of that? Okay? But just go to any public organization here, try to do something, and you will normally find something like, oh, sorry, sir, but this is not my role. So this is something that should not exist in new companies. This is something that is intended to be removed by making labor flexibility, but here it was presented as labor flexibility is firing one person and hiring another one. They made clear that the knowledge of the culture, the company objectives, and the company network is the biggest value that any person can have in a company, and this is the biggest loss if you change people. The concrete technical knowledge is something that can always be learned and can always be improved. Don't lose your employees, don't lose your organization. Make sure that everybody's on the same page, and then let them learn. This is more or less the message, and this is more or less the way these different technologies and approaches interrelate to each other, the way we are presenting it to you today. Do you have questions? I'm sorry if it was maybe a little bit less organized than planned, but I hope the message was understood. Anything you want to ask?
So we'll move on, and they'll still get some more shots. Go ahead.
Okay.
Be around so in case you have some questions. So we met a guy at a conference. His name is John Seddon. And he said, oh, there's nothing worse than lean. I hate it. And he's not alone. There's an awful lot of people that think badly of lean. And the reason is because it would take a little time to find the signal, I think. Yeah. Hopefully, yeah, there it is. And the thing is that lean has a really bad reputation because, just as Fernando said, some companies say lean, that means be efficient. That means we do more with less. That means figure out how to have fewer employees. Let's fire people. And there are implementations of lean, maybe not in software, but in other environments, in which it's all about getting rid of people, layoffs, and seeing how you can make people work twice as hard. Really a bad reputation. So lean has gotten, in some environments, a bad name. But if you go back to the origins in the way it was thought about by Toyota, and he didn't call it lean, by the way, he called it the Toyota way. He was, as Fernando said, thinking all about creating an environment where people could think for themselves and where people could handle multiple machines. And if, in fact, you found a way to be more efficient, then you produced more things and sold more. But you didn't create an environment that got rid of people. So lean has lots of different names and lots of different environments. When I first used it, it was a term from the 1990s. It was for manufacturing concept called just-in-time that we used in a factory that I was in. Let me ask you, how many here do software development? Okay, and how many here know about Agile? Okay, most of you, okay. And how many here do something called Scrum? And how many here think Scrum and Agile are about the same? Okay, it's a little bit different, but Agile... What?
At least I made that clear.
At least you made that clear, okay. I'm going to bring out some of the principles of lean, but not by talking about lean or even the principles, but talking about Agile and some of the ways in which a thing called Agile might not work. The thing about Agile is it's been around for 12 years now. And Tom and I have spent a lot of time going to companies finding ways that it doesn't work. So I thought, just for fun tonight, I would talk about the 8 failure modes that we run into in Agile, and the kinds of principles in lean that might help you to avoid that kind of failure mode, okay? So let's start out with no test harness. People chug out software, but they don't have a way to test to make sure that it works. Now, you can do this in lots of other areas besides software, but let's just take software for an example. We have heard at different Agile implementations quotes like this. Without Agile, you don't need to worry about documentation, right? Have you ever heard that one? Who needs documentation? People just talk, right? So why do we have to have documentation? Well, we've heard, we set out to do TDD, so we hired a Scrum coach, and what we didn't realize is that Scrum doesn't talk about TDD, so we didn't get TDD. That's a problem. We went to several places and we talked about TDD, test-driven development, and unit testing. And test-driven development is pretty much a unit testing technique. And we heard, you know what, you can't require unit tests. That's micromanagement. Teams should be free to decide which kinds of technical practices they want to use, right? Management shouldn't tell them that they should use TDD. Well, I happen to strongly disagree with that, but here's the sort of worst one that we've heard. You know, after 2 years of Scrum, our code base is a mess. The system we built is basically useless. If you don't have good technical practices, you typically, this is not uncommon, get a mess, because software is really a complex environment, and you have to have practices that build quality into the code while you're doing it. This is a classic lean concept. In our manufacturing plant, the idea is when you build something, you test it immediately. You never let the slightest defect get past the place where you're doing something. And in software, the big emphasis on testing has not to do with testing, but having to make sure that at every point in time, you know that your software works. You don't do stuff and discover days and weeks later, oops, you know that thing I did 2, 3, 4 weeks ago, or 2, 3, 4 months ago? Well, guess what? It's wrong. You don't ever want to hear that when you're developing software. Surely I never wanted to hear that when I was developing software. You need techniques to be sure that at any point in time, you know that what you've done is right. That you haven't done something that later on you're going to find out is wrong. That principle of lean, of build quality in, is really fundamental. And so if you look at some of the practices that are fundamental to make Agile work, and it's having a really healthy test approach. So this concept of quality by construction. A quality process puts quality into the code or into the whatever it is you're building. You don't test it in later. So rather than trying to do that, you have to have the opinion that if you're going to find defects at the end of your process, if you do stuff and later on at the end you test, does that happen? And all of a sudden, days or weeks after you do something, you find a defect. You've got a process that is defective. Your process isn't working for you. And any process, I don't care what label you give it, that finds defects way late in the process is a bad process. So think about tests as not tests, but specifications. Okay? Now, there's not too many software development processes that don't say, let's start with specifications. Okay? I've seen, stacks of specifications. If all you do is say, let's spend our time making things, test those specifications, testable. So when we do that, we can see if we've done it, we can test that. Then that's a good way of thinking about tests or executable specifications. They're the path to testable code. I have never seen testable code bases that don't have a test harness. If you have an untested code base, you have something you're never going to put under test. You have to build the test before you build the code. Tests are a safety net for change. Everybody says software is expensive to change. Why? It doesn't have to be. Amazon deploys new software every 11 seconds. and Google every day and Facebook maybe twice a week. How can they do that? How can it be so easy for them to change their code? It's because code does not have to be hard to change. It's hard to change if you don't have a test harness to make sure if you make a change, you haven't broken anything. Tests are not optional. Tests are not up to a team to decide what they're going to do. Tests are mandatory, or you're going to have a mess. And so I object to the concept that, let's let the team decide what kinds of technical practices they're going to have. Because code without a test harness means you're building legacy code, stuff that is going to be impossible to maintain over time. And I'm quoting my feathers, right? And he put that in his book, Dealing Effectively with Legacy Code. So your whole practice, check in early and often, and by the way, if your tests don't pass, you have to fix stuff. So where do we get this idea that we should have big, long defect lists? Many people are proud of how many defects they are able to find. They should be embarrassed. The idea that we have lists of defects means we have allowed defects to get into our code. And I hear again and again, well, of course code is going to have defects. Well, where did you get the idea that, of course, code should have defects? Of course it shouldn't, and it doesn't need to. And just the acceptance that, of course, there's going to be bugs in software always bothers me. We don't have to accept that as true. Not if we have really solid ability to put quality into the code from the start. There's a story about General Motors executives, and I think it was Gary Hamel asked them, why didn't you figure out what was going on with this stuff at Toyota? You had the Fremont plant. You could go and see what they were doing. Why didn't you adopt those practices in GM? And they said, we sent engineers to Japan. And we looked at what Toyota was done, and they'd come back and they'd tell us, you wouldn't believe the quality. And they would tell us that there was like almost zero, very low defect per million. And we thought they had their decimal point way off. We couldn't believe the kind of quality that they were talking about. And it was years before we began to accept the fact that you don't have to have defects in cars. Back once upon a time, there were lots of defects in any delivered car unless it happened to be Toyota. And it took a long time for the auto companies to accept the fact that you don't have to have defects in cars. Now it's time for us to say you don't have to have defects in code. If you know what you want and you can test that you've done it, you don't need to have defects in code. So that would be my first, no test harness. If you have an agile environment and you don't think that it's important to do testing, you're heading down the wrong path. System integration is not included in done. So teams are supposedly supposed to define what done means, right? You've heard that, okay? Do we allow them to define anything? One of the bigger problems I have found, maybe not so much recently, but for sure in the first 3 to 5 years of any implementation of Agile, they don't include system integration as part of done. It's ready to go to testing, so it's done. Ready to go to integration, so it's done. Wrong. Because the problem with that is that integration is where most of the defects are going to show up. So every software development process I have ever seen has as its primary purpose to find defects as soon as possible in the process. Every one. The waterfall process, its primary purpose was, hey, if we find the defects in requirements, then we are not going to find them later. So why don't we find all of the defects during requirements? Now, that worked when requirements didn't change over the whole course of development. That stopped working the day that the development cycle was longer than the change cycle. But for sure, the idea in the waterfall process was not to have this big testing at the end where you found defects. The idea of final testing is not to find defects. You're supposed to have already found them already. You're not supposed to be finding defects at the end. And that's also true in Agile. So if we have anything in our processes which find defects at the end, something's wrong. So, is there anybody here that has a release cycle of like 6 months or more? Okay. In your 6-month release cycle, do you have like a sort of testing and integration and hardening phase? How long is your cycle?
The testing cycle of integration.
Yeah, how long is your release cycle?
1 month it takes for the integration process.
Yeah.
Releases every 6 months.
Okay, and in your 6-month release, how much of that time is spent like testing and integrating and fixing things?
More than 1 month.
More than 1 month, probably 2. And I'm going to guess 2 because typically when we see release cycles that are 6 months or more, we see 30% of it spent in hardening, fixing, finding and fixing the defects every time. If you have shorter cycles, then it's going to be different. But when we see these long release cycles, we see, say, if it's 6 months, 2 months is going to be spent finding and fixing all of the defects, because you spend the first 4 months putting in the defects and the last 2 months getting rid of them, yeah. And that's what happens when you don't worry about systems integration really fast. Sometimes we see 50% of the release cycle just spent fixing, finding and fixing defects. Top companies, well less than 10%. And a good agile process will say that before release, you're going to spend less than 10% of your time finding defects because you already found them. So why does testing at the end seem like such a good idea? I don't know where we got that idea. It certainly didn't come from manufacturing, where I was. We have to get rid of the idea that testing at the end, its purpose is to find defects. Testing at the end, validation's purpose is to not find defects. So let's talk about your 6-month release cycle. So let's think about a little value stream map for a 6-month release cycle. Every 6 months we release. Okay, got that? And that means that we have this hardening, you know, for the last 2 months of our 6-month cycle. And maybe we also have some user acceptance testing out here, possibly, yeah. And here's where we develop, right there. So that's 4 months. And I'm going to bet that you guys decide what you're going to do in the next release before you start programming, yeah? Before the release starts?
Yes.
Yes.
Yes, and sometimes during those,
But you would like to have it done before.
Yes, sure.
You might change, and everybody that has long release cycles, somehow they get the idea that they have to figure everything out before the release cycle begins. I don't know why, but I think it's because 6 months is so long that everybody's on their case, so they want to know what they're going to get. So when you have this long cycle, people always tend to put design there. Okay, so that means that any request for a new feature is going to arrive in the 6 months before this choosing step, this design part starts, the choice part starts, right? So here's 6 months, which means your average receive of a request to do something is here, and the average time that the customer is actually going to get it is here, which is a year. Okay, it's not a 6-month cycle, it's going to take a year for anything. And even if it's a week's worth of work, so let's pretend that everything is maybe a week's worth of work like this. So if that would be true, the amount of time it takes to do the work is a week, and the amount of time it takes to get it is a year. Now, you know what? Customers don't like that. They get that it only takes a week, and they hate it when we take a year. So we have it even worse. I'll bet you that when you're trying to decide what to do, you have a whole list of stuff already there that's been sitting around, big long backlog of stuff you want to do. So that means that your requests for features have been arriving all for this long time. So your average start time is well over here, and you have a much longer cycle time than a year for a week's worth of work, or whatever a feature is worth. And that's displaying a really slow process. Releases are terribly painful because they've got this couple of months of fixing things. And so the idea is let's avoid releases, right? Okay, well, let's not avoid releases. One of the things we say in Agile is maybe we should not just do development and call ourselves done at the end of an iteration. Why don't we actually get it ready to release, or even at least go into system test at the end of every iteration? So I think every sprint or every iteration should drive code into systems integration. It shouldn't just be done. It should be ready to integrate into the system. Now, if that's true, if you buy that, yeah, you should have code that's ready to integrate, then the people who decide what done is not the development team. It's the systems integration team. It's the customers of the development team who are the people who are going to integrate. So done should mean ready to integrate. And the development team should understand from the systems integrators, what does that mean? So if we get to a quarterly, hey, this is twice as fast release cycle, that's pretty good. The first thing you want is you can't have that hardening or testing and fixing take any more than 2 to 4 weeks. I mean, after all, you've got only 3 months. And early integration testing has to happen, which means the end of every iteration, every 2 to 4 weeks, you have code ready to go into system testing. And by the way, this is something you all know. The longer 2 branches are separate, the harder they are to merge, right? So you want to merge them after every iteration, every 2 to 4 weeks. Unless you want to go to monthly. Wouldn't that be cool? How many here are at monthly? Monthly releases. Or roundabouts. Or longer. Okay? So with monthly, you can't spend any more than 3 to 4 days actually hardening, testing, and fixing your code, right? Because you've only got 22. And you have to have a cross-functional team because you don't have time for stuff to go all the way up to the top and the bottom down again. And you need to use visualization because there's just not enough time for everything to be discussed. Probably have short daily meetings. And you have to have not just TDD, not just unit testing working, but also integration testing or specification by example. That's what I mean by SPE. So you have to have not just unit testing, but testing whether or not you've got the right features working correctly. Automated and actually working. You can do this for web, for mobile, for cloud. You can do this for software as a service. You can even do it for internal software. But it's really hard to be delivering monthly to something where you have to deploy it off into another customer. What if, so this concept of system integration is not included in done, I think is a bad idea. And then let's go to the next step. How many people have ops involved in the done of their iterations? Anybody? Operations people? It's not done until operations people are ready to deploy it. Ah, okay. Well, that's the next step, guys. When you want to go faster than monthly, when you want to go to continuous deployment, then you really need to have operational people involved in your development. If done means released, if done means it's in, it's live, it's out there, where in production, doesn't necessarily mean that the feature's turned on, but it means that the code is deployed live. Then you should, then you're in this sort of weekly or daily or continuous release. In this environment, Kanban works well. Anybody here use Kanban at all? Okay, you know what it means? Okay, so Kanban works well, and by the way, iterations are too slow. When you're doing continuous deployment, you've outgrown your need for iterations. You've outgrown your 2-week kind of cycles. You might use cycles for creative work. You might want to use cycles to make sure that deadlines are met. But when you're deploying daily, generally people don't use iterations anymore. Estimating isn't really done. Why? Because, hey, you're deploying every day. And estimating isn't the issue. The issue is what should we do in the next few days. There's no branching with continuous delivery. You develop to the trunk. How many here are actually developing to the trunk today? Anybody? Couple. 3, 4, 5, 6. Good. And when you deploy to the trunk, you have to have ways to turn code off and on so that when you get a whole thing done, you can turn it on. Test and deployment automation is fundamental. So you've got to have your ops people with automated deploy and automated environments provisioning for testing, right? Otherwise, you can't be doing this. And perhaps the automated environment provisioning for testing is as important as automated deployment. Now, if you're in a cloud, hey, it doesn't matter. You don't have to have ops because you just use the cloud tools. But other than that, you have to have ops involved. And you have to have rapid cycles of learning to drive portfolio decisions. And it's by learning, by listening to customers and getting feedback, then the team decides what to do next. It's a very rapid cycle. I've seen it in a lot of companies. The company that was probably the first one I saw was in 2007. And when I saw this kind of daily delivery in 2007, I swear I thought they were crazy. I couldn't believe that they were doing it. Today, it's really common. The team includes everybody. There's no on and off the team anymore. And things just work. You can't do continuous delivery without extremely good discipline. What I'm going to call discipline on steroids. You really have your testing act together. You really know that you have testable specifications and your code is working at all times. And by the way, this is actually a very safe way to develop software because when you deploy small amounts, you almost never are in danger of massive failure because you're only making small changes at a time and they're safe, tested changes. This becomes a very disciplined and very safe way to do software. It's hard sometimes to convince managers that this is really good, that this is right now pretty much the disciplined way to do software. Now, it doesn't actually work for embedded software and for certain other kinds of very large projects, but it can work for any enterprise software, and it certainly has to work if you're in cloud or mobile or software as a service. It can be done in enterprise software, and if you happen to be there, or in government software, and you don't believe it, then check the work of Jess Humble, who works only in enterprise software and has definitely made it into a best practice. So here's discipline on steroids. You have a development stage, you have everything under version control with automatic environmental deployment. You have commit tests here at the commit stage. You have an artifact repository. So if you're audited by any kind of auditing agency, you can always show who wrote the test, when the test ran, that they worked or that they didn't work, when the changes were made. You have an acceptance stage. And generally speaking, you're going to have self-service deployment by testers. And these testers are not doing what we call monkey tests, just pushing buttons. These are smart testers who are trying to break the code by running manual testing and exploratory testing. You're going to have capacity testing, and eventually, preferably every day, you're going to be deploying to production, and then you're going to be designing the next step. So this is a very rapid cycle, and as I said yesterday, I think this is today's software engineering. So let me show you what I think are the fundamental technical disciplines that a team must have in place. You can have all the project management you want, you can have all of the Scrum processes in place that you want, but if you don't have these technical disciplines in place, you're really not doing good software development. And certainly, you shouldn't be doing Agile because you're going to create a lot of junk. You need to have a low dependency architecture. Agile wants to deploy rapidly. Tightly coupled monolithic architectures resist change. They don't like to be changed. And so there's a huge dissonance if you try to do Agile with a tightly coupled architecture. You need to move to low dependency architecture. You need some sort of coding standards. You need design and code reviews because every single thing out there that I've ever read says 2 sets of eyes on code is going to give you a lot better quality than 1 set. Refactoring, cleaning up the code as you add new stuff, is a habit. People do it as a matter of course. And they don't say, oops, you shouldn't change code once you wrote it, that's bad. They say, of course, code will constantly be improved as time goes on. You have a comprehensive version control system. You have automated unit tests. You have built a trunk. You have cascaded regression tests. That means your regression tests won't necessarily run every hour, but you'll run some of them over the first hour, and then you'll have a stage 2 of tests that don't fail very often, that you run maybe every day, and then you'll have the next stage of tests that almost never fail, that run maybe every couple of days, and if tests ever fail in your higher stages, you move them to the more frequent stages. So you have a cascaded set of regression tests that are constantly running. You stop if the tests don't pass, and figure out what's wrong, or at least back up the code. You deploy daily or more often. You release with toggles or switches so that you can turn features on and off. It means you can decouple deployment from release. Deployment means getting it out there. Release means letting customers see it. They're two different concepts. And this is your deployment pipeline, and then escape, defect analysis, and feedback. Anything gets past all of these defenses, you say, wow, how could that possibly have happened? We should not allow anything past these defenses. And you figure out what allowed it past, and don't ever let it happen again. So this is, as I said, very fundamental technical disciplines today for developing software. And you need to be moving in this place to have true high-quality stuff. Sometimes I have people score themselves how good they are. It'd be an interesting home exercise. Okay, another one, little thought to architecture. We just sort of put stuff together. Low dependency architecture is really important. There's this neat story about Amazon.com in the early days. When they started up, they had a massive front end and a massive back end. Classic strategy for almost every organization in the late 90s, early 2000s. Great big computer doing their front end, great big computer doing their back end. And the problem was that every single holiday, and we're heading into the holidays now, where there's going to be an awful lot of shopping, and they would just about die. And they would have this massive demand. And guess what? We're talking about 2000, 2001. And they knew that it was going to get a lot bigger from there. In fact, they started taking on companies like Target and doing their sites. And they would get through the holiday season, and they would say, whew, we made it. Okay, so all the executives do that. And they get 30 seconds, and then they look at each other and say, oh my God, what are we going to do next year? And, you know, there was no way to do next year until they changed their architecture. So they took 7 or 8 years to change their architecture. They started towards a service-oriented architecture in about 2001. And the concept there was, first of all, it's all about scale. And Jeff Bezos happened to believe that the only way to scale is to have small units of stuff, not great big massive stuff. And he decided that they should have what they call 2 pizza teams. A 2 pizza team is a team you can feed with 2 pizzas, 2 big Seattle pizzas, okay? 6 or 8 people. And a 2 pizza team owns a service. If you're on a 2 pizza team, you own that service, and you need to stay on that team. Your commitment is at least 2 years. So you there, that's your service. And a service has everybody necessary to make it happen, including people who are going to decide what to do, people who are going to actually code it, people who are going to test it, and operations. Why operations? Is because they discovered that 60% of all of their problems were in operations. So Bezos said, so why would we not have operations on the technical team? So ops was part of the development team, of the service team. And services owned their whole sets of problems. And they had contracts with other services. They said, we will be able to take requests at this kind of rate, and we will be able to, they said, here's the rate at which we can accept requests, those kinds of contracts. And here's our input, and here's our output. So those 2 pizza teams own a service, and if a service is too big for the 2 pizza team, they split the service. Because they like to have these independent teams that are creating all these different things on their website. You can kind of almost see if you go to the Amazon website. here's the one that does reviews, and here's the one that does, there's two kinds of services. There's consolidator services that'll put together pages, and then there's separate services that might take a review and do it or something like that. They encapsulate data and business logic in the service. They don't have databases anymore. No more databases at Amazon, because that's too fragile. And it can lock, and they don't have any space for locking services. They completed the transition in 2009, and then they started, as you know, to sell them, called Amazon Web Services. They now make about $4 billion a year selling these things. They designed all of them to be exposable to the public and usable by other people, instead of making them proprietary, which I find interesting. Most companies want their specialty, really good stuff to be proprietary. Bezos says, I want it to sell. And sell they do. They make a ton of money. So Conway's Law says, if you've heard of this, organizations which design systems are constrained to produce designs which are copies of the communication structures of the organization. By having these little two pizza teats, he got little two pizza-sized services. And those are the services which they now sell. And this low-dependency architecture took them 7 years or 8 years to get to. It's not something you get to overnight. But if you're not trying to head there, you're always going to be fighting this big interlocking monolithic architecture that is so hard to change. One thing I want to tell you about testing, automated test, is you have to structure your test just as well as you structure your code. So the architecture of your tests is just as important to be loosely coupled as your services, or as your architecture. So you need to create a well-factored test harness, not just well-factored code. So you should structure every single new effort that you do, new feature, new something. It's going to be a component, it's going to be a service, or maybe it's an app, okay? And each team will write internal tests to be sure that their code behaves correctly, and then they're going to write contract tests to assure that any code which calls their code does it right. And then other teams take those contract tests and they run them. So if I'm going to call your code, I pull your contract tests and I run them and make sure that those tests behave. And then if they do, that means I can call you safely. So each team assures that their component works correctly, their contract tests reveal any incorrect calling instances, and they pass the contract test for any components that they call. And if you do that, you can have a ton of small services and a very well-factored test harness, not one that gets out of control. And you can really probably have an architecture that you can live with and grow over time. So enough of that one. Little thought to architecture, both in the testing and in the code, is one of the big failures. So I haven't talked a lot about process yet. I've talked about a whole bunch of technical things. And the reason is because we live in a deeply complex technical world, and if we think it's all about putting a simple project management process on it, and then everything will be fine, we're nuts. That's not going to do it. We need to build quality in and have high-level technical processes that work. Here's my next one. The next biggest failure of Agile, and it does it way too often, is almost every Agile process that I've seen has a big tendency to build the wrong thing. Okay? Build stuff that isn't necessary. So here's my biggest problem with software, and that is extra features, in my opinion, I think if you were there yesterday, you heard, are the biggest waste there is. We just put way too much junk in our code. This is a scheme that, research that was done in 2001, so it's very old, but I don't think it's very strange. I think we still see it. Something like, in this custom software development, 2/3 of the code that they looked at was seldom or never used. Didn't need to be there. Not stuff we hoped wouldn't ever be used, but it you know, safety stuff. Stuff that never needed to be there. 2/3 of the code of most custom software that I've looked at, or maybe 50%, because you're much better than these guys, right? Doesn't have to be there. That's an awful lot of stuff that we didn't need to develop, test, you know, and let our code become more complex. Typically, only 20% or more of the code that you see that comes from this let's figure everything else out upfront process really is stuff that has to be there. It's one of the reasons why Agile is so good, is because it says let's think of the 20% that we really need. Let's get it out there, let's make sure that it's right, and then let's add stuff. And the problem with having all of this extra code is all we're doing is driving up the cost of our code base with all that complexity that all that extra code adds. So I really think that the biggest way to increase productivity in software development, I mean, are there enough software developers here in Uruguay to do all the work that's necessary? Or do you need more? Okay. So if you would like to have more, the best way to get them is for those of you who are software developers to stop developing so much code. Okay, if half of what you do doesn't need to be there, maybe if you could figure out which half that is and not do it, then you'd have twice as much time. Actually, more than twice as much time because of the complexity curve. So the thing that you got to understand is the biggest opportunity for productivity improvement is to write less code. So you never measure productivity by number of features you put in or number of lines of code, because, you know, features and function points and lines of code are all bad things. All they do is create complexity. And unless they happen to give us the thing we're really looking for, the end result that's really necessary, they are simply waste. And they're bad waste because they suck up your time, they suck up all of this, they add all of this complexity. So code is not good. Code is fundamentally bad stuff. Really good developers don't develop so much, they develop less. Really good teams take code out. They don't put code in. Because it's all about doing the stuff that has a high impact and is simple. It's not about putting as much junk into the code as you want. So if you think about that, the thing you need to do is to make sure that everything that you do is stuff that's going to have an impact, that's going to be what customers want. And although Agile's good at saying, hey, let's find this 20% and do it, it's not really quite so good at making sure that what the team does is really what is going to have impact. Because unfortunately, it's way too often what somebody thinks is the right thing, not what somebody knows is the right thing. So we got to stop building the wrong thing. In the lean startup world, the idea is to build a minimum viable product, the smallest thing you can think of that might work, get it out there, measure the response, learn, and then keep going through that cycle until we figure out what is the stuff that's going to have the impact. So here's a really interesting experiment that was done at, this is Amazon.com. I'll tell you first about an experiment that was done at Microsoft. Microsoft took their product managers, okay, all of those guys that are supposed to decide what's supposed to go into software, and they had them say, here's the feature I want, and here's the impact that it's going to have. And so they conducted tests where they developed the feature and then measured the impact and said, hey, does the impact match what the product manager said, or is it anywhere close? And they discovered that the product managers, whose job it was to know what features to put in there, were right about 50% of the time. So you could flip a coin and be just about as accurate as those product managers in deciding what features. So that's why you don't want to just believe what somebody says, even if it's their job to know, because they don't necessarily know, they're guessing. And most good product managers would love this kind of process because they know they don't know what it is that needs to be done. And having a way to find out and test is much better for them and for any team than it is having somebody who tells the team this is the thing to do next. It's much better to have a team involved in experimenting. And when you do this, trying it out on a certain percent and measuring your response, you have to put in some stuff that developers and ops are much better at than marketing people. So you need the whole team involved in this whole process of trying out the feature and seeing if you get the result. So let's, another funny story, and this happens to be an Amazon story, about a guy named Greg Linden. He actually, I think, has moved to Google subsequently, but he created a prototype. And this prototype, it's interesting what it does because you recognize this. It says, say you have decided that you want to buy some things. You remember down below it says, people like you have also bought, people that bought this have also bought these things. You've seen that? Okay, well, it didn't exist once. It wasn't there. And Greg Linden said, you know, I wonder what would happen if we showed people that wanted to buy something, other stuff that people that bought that wanted. And he wanted to do an experiment to see if that would be a useful thing to do. And the head of marketing, the vice president of marketing said, Greg, there's something you don't understand about marketing. When somebody's decided to buy something, you never interrupt them. You do not bother them with stuff. So no, absolutely not. You cannot do that. It's a bad idea. Forget you ever thought about it. Okay, those were his instructions. But he wasn't a very obedient guy. And he also knew that data was the thing that Amazon lived and breathed on. So, you know, against the wishes of the marketing vice president, he set up a fairly sophisticated test to test whether or not this idea of people who bought this thing was actually useful. And he had to get permission then to run the test because it was a fairly big, sophisticated test. And the marketing vice president was really, really angry. But unfortunately, at Amazon, data is the winner. And so he decided that he had to let the test go and let Greg find out how dumb he was. And as a matter of fact, it turns out that the experiment showed uniformly you increase sales by 3% if you do this thing at the bottom. That's why I said it. Because they get 3% more sales because they show you what other people like you have bought. And it's even the head of marketing, his instincts on what people want when they're about to buy, they were just plain dead wrong. And a good test is a much better way to figure that out than having some expert tell you. Oh, here's the one about on Microsoft. I forgot I had it here. Most of the time, we guess about how customers are going to behave. Buying product managers will be wrong over half of the time. So the concept here is test early. Don't waste a lot of time with in-depth analysis. Forget the planning. Why? Because you're going to be wrong anyway. Not completely wrong, but wrong enough. You know, you'll make enough of a mistake that it would be much more useful to find the information out with a test than it is find the information out with a guess. And you want to test often because not all experiments tell you very much, but there are the ones that are going to tell you some very valuable information. So this idea of the product owner as the only person telling the team what to do is, in my opinion, a really bad idea. Because we don't want anybody, and I don't care what their title is, saying this is the right thing to do. We want the team involved in learning what the right thing to do is. And before there was Agile, this is the way things used to be. You guys might not remember way back then, but there was a time when the development team was expected to figure out what to do. And then there was this, oh, but we don't want them to make mistakes, so let's make it somebody else's responsibility. And so we got this sort of intermediary that hands over to the team what it is that they're supposed to do. Now, they don't always do that, but when you look at the definition of how it's supposed to work, there's this thing, the handover. And Alan Ward, who writes about lean product development, says that handovers are absolutely the biggest waste in product development because of lost knowledge. And a handover occurs whenever you separate responsibility, knowledge, action, and feedback. So one person decides what to do, somebody else figures out how to do it, third person actually does it, fourth person learns from the results. That's a handover. And that is where knowledge gets lost. So this is not the idea. Somebody goes out to the market and brings a prioritized list of stuff to developers to do. This is not the idea. The idea is that a product leader with some title or other, you can name them whatever you want, make sure that the team understands the market and runs tests in the market to figure out what's the best thing to do. So we need to move from this to this. So if you look at this book here, it's called The Design of Design. It was written by Fred Brooks. Does that ring a bell? Fred Brooks. Fred Brooks wrote The Mythical Man Month. Does that ring a bell? Classic software engineering book. And about 2 years ago, he wrote the book The Design of Design. It's a collection of articles he's written about software, about design in general. And he basically says, we need to learn that the first thing we do in software development is solve the right problem. In fact, deciding what to design is the hardest part. So figuring out what to do, that's tough. So we need to go beyond analysis, we need to go to insight. Design isn't to just satisfy requirements, you gotta uncover what those requirements are. Design isn't to select from alternatives, you have to realize the alternatives exist. So we're looking for a product leader that makes sure the team does this. The team gets insight into the problem and understands what the alternatives are. And his very big thing that he says in the book is, the biggest problem that happened in the 20th century is we divorced design from implementation. And it didn't used to be that way. The progressive divorce of the designer from the implementer and the user has led to all kinds of disastrous and costly and embarrassing miscommunication. So this, friends, this is not design. That's just a stack of stuff. But that's not design of what we really need to do that will have impact and really make a difference. And we need to get the team thinking about what is going to have impact and make a difference. So don't divorce design from implementation. Straight out of Fred Brooks' book, he says, how do you do that? Well, one way you do it is use scenario experience. So those who are actually coding should experience the thing that they're doing. He gives an example of Philippe Couchet, who did the Canadian air traffic controller system. And he had all the developers sit in air traffic control towers with air traffic controllers for a long time, understanding what air traffic control was all about and what were the problems and what were the issues. He felt if the developers didn't experience the thing they were coding, they would not be able to do a good job. And the other thing is the design should make sure that implementers and designers are talking with each other all the time. Not just somebody does the design on somebody who's supposed to code it, but the people who are going to implement and the people who are going to design have constant conversations throughout the entire process. And you want incremental specification, not big front-end specification. We kind of know that in Agile, at least we kind of think we know it, but it's really fundamental. Product features are iteratively and incrementally added. And lastly, we need constant ongoing feedback from the part we've done so far to the development team so they see how things are going and learn more and more about the world they're in. So I'm at number 7. Well, not too late here. Lack of competency leadership. So we have leaders, none of which I actually like, specified by some of the Agile processes. But I never see this particular leader. And in fact, I see sort of a, we don't need this kind of leader, a competency leader. Somebody who really understands testing or high volume transactions or database or all of those detailed specialties that we need to make our code really work. So we have people that come in from I don't know where, and suddenly they're experts. But where is the person in the company that's making sure that if we have a special competency that we have to be really good at, that we really do it right? Whether it's user interaction design or any of those other specialties, we need somebody who makes sure that the people that know how to do that well are hired, work together to become better in their specialty. That's not to say that they can't help other functions, other areas, but there is a need for specialization in a deeply complex environment like ours. And there is also a need for competency leadership. When I was working at 3M, we had the concept of a competency leader as a teacher. So we had a competency leader, and that person was, yes, our boss, but also our teacher. So their job was very much like a university professor, making sure that we understood the area that we were going to be good in. I did software for process control systems. My software controlled great big 3M roadways processes. Lots of specialization there. And I was in an environment where my boss was a really good control engineer. And having a control engineer for a boss was fundamental to learning about doing good control engineering. So when you have a product, what you're trying to do in product development, and this is according to Alan Ward, is to go from a concept to cash, and you want to produce both the product and the value stream that's going to produce that product, or the process that's going to produce that product. So for example, when the new Lexus was designed in Toyota, they didn't just design a Lexus, they designed all the new manufacturing plants that were going to manufacture that high-tolerance car. Because none of the existing manufacturing plants could actually manufacture the car. So they did not just the Lexus, but they designed the whole process of manufacturing it and selling it at the same time. So you have a competency, a product leader, somebody that really understands the technical opportunities and has a deep market understanding. Maybe it's 2 people, possibly 3 in some environments. And so the customer has a job they need done, and they have some outcomes they value. And then you have a technical team, okay? And the technical team is, you know, like sort of here's your band leader and here's your band, bringing different technical competencies to the team. And they also are creating useful knowledge in their particular domain. Here's a better way of doing testing. Here is a better way of doing user interaction design. Here's the way we should standardize on these kinds of screens. Those kinds of things go into an environment where a competency leader makes sure that other people in that same area learn that stuff. And they bring innovation, integration, and good decisions into the product development process. So the way I look at leadership roles is a little bit different than you might have heard in Agile. And this is just for your consideration. If you think about this guy, okay, who doesn't know really exactly what to do, he's maybe relatively new and junior on the team. He has 2 ideas, 2 questions. What do I do next? And how do I do it well? Telling him what to do next is going to be, say, the entrepreneur that's starting up the new company, or the product leader that understands how it is that the product is going to make money. And this person needs to be market focused. They need to understand what the market wants. They have business responsibility for making good decisions. They understand customers. Maybe they do release planning and understand trade-offs. But they also provide technical leadership. Now this could be 2 people, could be 1. But we don't want just a market leader. We also want a technical leader, and we want them to be, if they're 2 people, equal to each other. Because there has to be trade-offs between technical and market decisions in product development. There will always be trade-off between technical and market. And if you don't have 2 people of equal stature having fair arguments with each other, then the guy that's senior is going to win. And we can't have the market guy win all the time. And we can't have the technical guy win all the time. We have to have these guys having really good fights. Yes? And we have to have them be fair. So either this is one person who integrates all and is responsible for both, like a chief engineer, or it's 2 people that are of equal stature. So not having a technical leader on a product team, I think, is a mistake. And when you have a product development team without these 2 roles, you tend not to get, I bet you, quite such a good product. Really good products tend to have a product leader or two, or sometimes three, with a design focus, doing these two things. And if it's got a lot of user interaction focus, then I would add a design leader to here, or one of these would also act as a design leader. And then you need your teacher, okay? The one who's going to help Klaus, help our newbie here, know what to do well. How does he do his job well? Say he's a tester. How does he know how to write really good automated tests? So he has a competency. And the competency leader makes sure that they preserve knowledge in essential competencies for the company. They develop expertise, they act as a teacher. And they might be a people leader, somebody to mentor people to reach their full potential and teach them how to solve problems, which is my last point. So I look for good leaders in these areas, and you'll notice that there's not a single title in any of the Agile practices in my set of ideal leaders. Right? You don't see them, and I'm not sure they're necessary. I do see a process leader, sometimes called a Scrum Master, as a sometimes needed wing of a new process. But over time, that role evolves to this area here. And that person, I mean, it's not to say that there doesn't need to be a process leader, but that is something that usually evolves in the normal organization, not something that's separate. Because if you have one of these and one of those, they tend to say, okay, who has to decide? And I would propose the competency leader or people leader. Then we have project managers or release managers. And it's interesting to talk about project managers, but if you already have